So today we're going to be solving quadratics. I've already taught you how to solve them in your calculator. Can anybody remind me how to solve them in the calculator? Set them equal to? And then what are you looking for? Where they intersect the x-axis. So if it intersects once, then there's only one answer, right? If it intersects twice, there's two answers. And if it doesn't touch the x-axis, it is no solution. Well, today I'm going to teach you that you can also use what is called a square root to solve quadratic equations. This only works when the middle term, the b, is missing. So write this down, ax squared plus bx plus c equals 0. So if this term, here we go, is missing, you can use square roots to solve quadratics. Now, in this case, you don't set it equal to 0. This is a whole different way to solve them. If you don't like this way, you can literally just set it equal to 0 and put it in your calculator every single time. But this is something that I have to show you guys, okay? So what you would do is you would solve the equation like you would do normally, like isolate the x. How would I get rid of the 2? Divide both sides by 2. And I would have x squared equals 4. Now, to isolate the x, how would you know how you do the opposite, the inverse operation, right? So what did we do a second ago? 2 was being multiplied by x. What's the opposite of multiplying by 2? Dividing by 2. Well, x is being multiplied by itself. Yes, it's being squared. What is the opposite of squaring something? Square rooting. So if I square root the left side to balance the equation, what do I also have to do to the right side? Square root. And so I'm left with x equals the square root of 4. Now, we learned a while back ago that square roots actually have how many answers? 2. So I want you to think about it. What is the square root of 25?
5.
What's the other square root of 25? Negative 5. Why? 5 times 5 is 25, but negative 5 times negative 5 is also 25. So this will have 2 answers. It will be plus and minus the square root of 4, which is 2. So you can either write positive 2 and negative 2, or you could just put plus and minus 2. So this is a parabola that crosses through the x-axis at negative 2 and at positive 2. Are y'all with me? Now again, this only works when the bx is missing. All right, let's try this one. Isolate the m by adding 18, yes? If I add 18 to this side, what do I have to do to the right? Add 18. I'm left with m squared equals 0. To get rid of the squared, the opposite of squaring something is square rooting. And so I have m is equal to the square root of 0. Now, 0 times 0 is 0, and there is no positive or negative value to 0. So the answer is simply 0. So if I graphed this quadratic and made a parabola, it's only going to touch the x-axis one time at 0. All right, let's try this one. How would I get rid of the plus 12? Minus 12. I'm left with b squared equals, and 5 minus 12 is negative 7. To get rid of the square, I must square root both sides, and I'm left with b is equal to the positive and negative value of the negative square root of 7. Now here's the problem. Can you square root a negative? Watch what happens. Is anything times itself ever going to give you a negative value? No, the square root of negative 7 doesn't exist. It's not real. Think about it. Is anything times itself a negative value? No, what's the only way to get a negative value? Multiply opposites, right? Multiply a positive times a, and that doesn't make sense. So this would never touch the x-axis. So what would my answer be? No solution. All right, let's try this one. isolate the x by getting rid of the plus 11. How would I get rid of plus 11? Minus 11. I'm left with 2x squared equals 0. Now I need to isolate the x by getting rid of the 2. How would I get rid of multiplying by 2? Divide by 2, and 0 divided by 2 is 0. How would I get rid of the square? Square root, and x is equal to 0, because the square root of 0 does not have a positive or negative value. It's simply 0. Y'all have questions on that? Does that make sense? Okay, again, if you're on the EOC or you're just like, how do I solve a quadratic? You can always set it equal to 0 and put it in your calculator. So every single one of these could still be solved the way I taught you originally. They could also be factored, yes? And then each factor set equal to 0. All right, now we're going to talk about what if it's a fraction. You can square root fractions, okay? So how would I isolate this z? Divide by 4. So I have z squared is equal to 9/4. Now don't turn that into a decimal. Think about this. Are 9 and 4 both perfect squares? Like, can you square root 9 and get a perfect number? 3. Can you square root 4 and get a perfect number? 2. So just leave them like that, okay? Like, don't go turn it into a decimal. All right, how would I get rid of the square by square rooting? And I'm left with z equals. Now, what do I have to put in my answer? The positive and the negative answer. And guys, it's this easy. You don't need your calculator. The square root of 9 is 3. The square root of 4 is 2. Now, if you needed your calculator, it would also give you that answer. All right, do the same one. How do I isolate the s? Divide by 25. And then I would square root both sides. That gets rid of the square, so I have s is equal. But don't forget, in your answer, you need a positive and a negative answer. The square root of 49 is 7. The square root of 25 is 5. Okay, moving on. Divide by 9 on both sides. And then square root both sides. So m is equal to the positive and negative. What's the square root of 100? 10. What's the square root of 9? 3. So it would touch the x-axis at positive 10/3 and negative 10/3. Are we good? All right, this next one I would divide by 16. So I have c squared equals 64 over 16. I would square root both sides, and I'm left with c equals the positive and negative version of, what's the square root of 64? 8. What's the square root of 16? 4. Now, can I simplify 8/4? What is 8/4? 2. So I have c is equal to the positive and negative 2. So it touches the x-axis at positive 2, and it touches the x-axis at negative 2. Now, that's if they're perfect squares. Can I use this if they're not perfect squares? The answer is yes. But you would usually just leave your answer as a square root. Notice we took the square roots off because they're perfect. Yes? So now let's look at some that aren't perfect. Notice it says approximate solutions to the nearest hundredth. So you can take it out of the square root and round to the hundredth place, or you can leave it as a square root. All right, so here we go. How would I isolate the x? Ooh, what do I have to do first? Add 11. So I have 3x squared equals, and 7 plus 11 is 18. Now how do I isolate the x? Divide by 3. So I have x squared is equal to, and what's 18 divided by 3? Why didn't I go ahead and square root? Because they're not perfect. Y'all agree? You cannot square root 18 and get a perfect number. Everybody agree? Okay, so I'm just going to leave it as 18 what's 18 thirds? 6. Now I need to get rid of the square by doing what? Square rooting, both sides. The square root of 6 is not a perfect number. So I can either leave my answer as a square root and say x is equal to the positive and negative square root of 6, or I can round to the nearest hundredth like it asked me to. So I would simply go to my calculator and say, what is the square root of 6? So my answer is positive 2.45 and negative 2.45. So instead of writing it twice, I would say x is equal to positive and negative 2.45. Do y'all want to try one on your own? Okay, check your work with mine. How did we do? Good? Questions? All right, let's do 2 more of these. You have a question?
You get 2.83.
So square root of 8. How did I get 0.83? Go back to 3rd grade. Okay, how do we round? If I'm rounding to the hundredths place, that's the second decimal, yes, because this is tenths, hundredths, thousands. I look to the number to the right. If it's 5 or more, raise the, there we go. Remember now? Okay. All right, let's do this one. So I would subtract 4 on both sides. I have x squared equals 10. I would square root both sides. And I have x is equal to positive and negative square root of 10. Okay, since it told me to round to the hundredths place, I have to take it the next step. If it didn't, I would leave my answer like that. But it did, so I'm going to do the square root of 10. And I'm going to say x is equal to positive and negative 3.16. All right, next one. How would I isolate the k? What do I have to do first? Add 1 to both sides. So I'm left with 3k equals 1. Then I would divide both sides by 3. And I'm left with k squared is equal to a third. How do I get rid of the square? Square root both sides, and I'm left with k is equal to the positive and negative square root of a third. Since it told me to round to the hundredths place, I have to take it a step further and say, what is the square root of a third? And it is 0.577. So what would I round this to? 0.58. So I would say k is equal to positive and negative 0.58. That means it touches the x-axis at positive 0.58 and negative 0.58. Yes or no? Everybody good? All right, now we're going to look at some interesting quadratics that we can still solve using this method. So turn to the next page. It says solve the quadratic equation. Now, could I set these equal to 0 and just use my calculator? Yes or no? Wake up, guys. Yes, but is that what I'm teaching you how to do today? No. So we're going to solve these by the square root method. Now, what is your job? To isolate the x. So this whole side is being multiplied by 6. So how can I get rid of that 6? Divide by 6. Whatever I do to the left, I have to do to the right. So I'm left with x minus 4 in parentheses squared equals, and 42 divided by 6 is 7. Are y'all good with what I did? Okay, now, this whole side is being squared. Do you all agree? I cannot get rid of the 4 first because this whole side is being raised to the second power. So can I counter that by saying, can I square root this whole side and square root this side? And that square root cancels out that square. Yes? I now have x minus 4 is equal to plus or minus the square root of 7. Is x by itself? Yes or no? No. How do I get rid of a minus 4? So I have x is equal to positive 4 plus or minus the square root of 7. And I'm just going to leave my answer like that. Now, what does that mean? That means if I put in my calculator 4 plus the square root of 7, that is where it touches the x-axis. I also would put in my calculator 4 minus the square root of 7, and that's the other spot it touches the x-axis. Does that make sense? Yes or no? And I'm going to show y'all. Y'all don't have to do this. I just want you to look at the board. These are our two answers, yes? If I go back to the original equation and I put in 6x minus 4 squared, and I move this 42 to the left by subtraction, and I set it equal to 0. Those are the two answers. We're going to see if they match what we got. So the first answer is here, and it is touching at 1.354. Everybody look. Was that one of our answers? Now let's look at the other one. My cursor went way far. There we go. So the other answer is at 6.645. Was that the other answer? So do you see that you're going to get the same answer no matter which way you do this? Yes? Okay, let's go do this one. My job is to isolate the x. This whole side, do y'all understand why I can divide by 4 first? The whole side is being multiplied by 4. So to get rid of 4, I'm going to divide by 4. That cancels out. And I'm left with x plus 6 raised to the power of 2 equals 32 divided by 4, which is 8. Now, I cannot get rid of the plus 6 like normal because this whole side is being raised to the power of 2. So to counter that, to do the inverse operation, because the whole side is being raised to the power of 2, the whole side can be square rooted, and that will now cancel it out. I can now square root the other side. I now have x plus 6 is equal to the positive and negative answer to the square root of 8. But x is not isolated yet. So I need to get rid of the plus 6. How do you get rid of a plus 6? Minus 6. Now when you put it over here, you're going to put it over as a negative 6. Yes? So I have x is equal to negative 6 plus or minus the square root of 8. And that would give me two answers. I would have to put it in my calculator twice. Negative 6 plus the square root of 8, that's one intersection. Negative 6 minus the square root of 8, and that's the other intersection. Does that make sense? Yes or no? All right, I want y'all to try this one on your own. All right. Do y'all notice that the square root of 9 is a perfect square? Yes? But I would leave it like this at first. So I have x is equal to 2 plus or minus the square root of 9. Now you could say the square root of 9 is 3. So 2 plus 3 is 5. And 2 minus 3 is? Anyone? 2 minus 3 is? So you could leave your answer like this, or you could just go ahead and say it touches at 5 and negative 1. All right, do this one on your own. All right, how'd y'all do? Questions? All right, let's look at the last one. It says, during an ice hockey game, a remote-controlled blimp flies 45 feet above the crowd and drops a numbered table tennis ball down to a person in the stands that is 17 feet from the ground. The number on the ball corresponds to a prize. Use the vertical motion model to find the amount of time that the ball is in the air. Now, we've been talking about the vertical motion model, so let's write it down. H equals negative 16t squared plus vt plus s. And let's go over what each piece represents. The h is the height. The v is feet per second. And the s is the starting point. So let's look at what they gave us. It says, okay, a remote control blimp flies 45 feet above the ground, above the crowd. Is that the starting point? Yes, so this is going to be 45. So this is going to be our S. It drops a numbered table tennis ball to a person in the stands that is 17 feet from the ground. So it's not going to the ground. So we're not trying to set it equal to 0. We're setting it equal to the height where it's going, which is at what? So that's the h. So let's go fill in what we know. 17 equals negative 16t squared plus vt, which it didn't give us that. So that's missing, which it should be, because what's our lesson about? Using the square root method, and we shouldn't have that. Okay, plus our starting point, which is 45. Now, could we solve this using the square root method? Could we also set it equal to 0 and then solve? Yes. Okay, so square root method, I got to get the t isolated, so I got to get rid of the 45 by subtracting. So I have negative 28 equals negative 16t squared. To get rid of the negative 16, how would I do it? Divide by negative 16. Negative 28 divided by negative 16 is 1.75 equals t squared. And then to get rid of the squared, what would I do? Square root both sides. So my answer is the positive and the negative square root of a 1.75. Now here's the problem. We're talking about seconds. Can you have a negative second? So would I even consider the negative as my answer? No. So what is the square root of 1.75? About 1.32 seconds. Okay, if you would put your name on it. We're going to do the whole paper. It is super, super easy. On 1 through 3, you must write both answers. How many answers does a square root actually have? A positive and a. I am perfectly fine with you writing, like if it's the square root of 25, plus or minus 5. Yes? Okay. On 4 through 6, it says isolate the variable in the equation. Guys, that just means solve it. Okay, so for this one, I would plus 18, divide by 9, and square root both sides. Make sure your answer is a positive and a. You can leave it as a square root. Do not round. So put it right here. Leave as a square root. So if it's like the square root of 7, I would put plus minus square root 7. Yes? Does that make sense? All right, on 7 through 12, I want you, on this one, the square roots are perfect square roots. Yes? So go ahead and square root them. So like if you get the square root of 4, you would put 2 and negative 2. So I just put plus minus 2. Okay? On 13 through 15, what does it say though? It says round your answer to the nearest. That means they want you to actually square root it, but how many answers will there be? Positive and negative, whatever. And you're going to round to the hundredths place. 16 through 18, also round to the hundredths. So they want your answers as decimals. Guys, if you forget to put positive and negative, you're going to miss a whole part. Yes? Because there's two answers, the positive and the negative. So whatever you get, you're going to get a positive and a negative. All right, 19 through 21 says use the given area of a circle to find the radius or diameter. So, let me see. Round your answer to the nearest 100. Do y'all know how to find the area of a circle? Area equals pi r squared, right? So, if area equals pi r squared, they're saying the area is 25 pi. So basically, you're just saying what number times itself was 25. You see what I'm saying? Yes? So, would you need a positive and a negative for radius? Yes or no? All you need is the positive. All right, 22 is super easy, it is super easy. And then for 23, you're going to find all three radiuses if the height is this and the capacity is this. Round to the nearest inch. That means whole number. Round to the nearest whole number.